All righty, we're looking at problem two. Now we again have these two spheres. So you can see the picture here. All right. And we are going to hold them at a certain distance. Okay. And we're going to know the force on them. And so let me just write this down. So we know the distance of separation. R is equal to 0.48. This is just my problem, and yours should be different. And the force on the charge is going to be, what is the force? The force is 0.16 newtons. So we want to know what is the charge. So of course we're going to use Newton's, I'm not Newton, but Coulomb's law. And we have kappa Q1 Q2 over R squared. This equation implies that the Q, so Q1 and Q2, well, first of all, Q1 and Q2, they are just going to be equal to Q. And so they're equal to one another. So and before I write the implies, let me just erase this and let me rewrite this equation as F sub Q equals to kappa times Q squared over R squared. So let's go ahead and solve for Q squared. Q squared is just going to be F sub Q times R squared, and then that's going to all be over kappa, okay? And so I can take Q, and then I'll just find the square root of this over kappa. So that's how, we're going to find this. And of course, I'm going to use Microsoft Excel again. And let me pull this up. And so let me just duplicate this sheet and let me rename this sheet. Can I rename it? Yep. So this is going to be problem one. And then I have this sheet and I want to rename that one problem two. Okay. So instead, so we want to find the charge in this particular case. So we don't know this, okay? So I can get rid of these two columns and I'm just going to say delete. And we know our distance, okay? So our distance in my case is 4, 5. And in this particular case, we don't need any of this. We were given the force, and the force is 0.16. And so we want to calculate the charge. So what is the charge on each sphere? All right, so this is capital C. All right, so we know our formula, and our formula basically, I can just bring that up instead of trying to guess or remember. So the formula here is going to be equal to, and I can just type in SQRT for the square root, okay? And that's going to be of the force. So we have our force here, and I'm going to multiply that times the power of, and I'll just select power of the distance between the two spheres. It's not W, it's actually 2 because I want it to be squared. And I'm still in the square root. Am I not? Yeah, that's it. And so that's just for the power. And then we're going to divide this by k. So I was just really trying to avoid writing this very long number over again. And then we're going to close our parenthesis, our parenthetical statement, and we have the charge on each sphere. So it looks like we have two decimal places. This gives us two significant figures, so I should be able to write this in as 1.8, 1.9 e negative 6. Let me see if that works. All right, so that didn't work. Let me see. Looks like we actually have to use scientific notation. Hmm. Let me see if this will work. Let me use the multiplication sign. 10 negative 6. All righty, that didn't work. Hmm. Okay, so you do have to use the asterisk. I would say don't put any spaces between it, and then you have 10. And in my case, I have to the negative 6, so I have 10, and then I use the caret key, and that's shift 6 for that little hat, and then negative 6. And so my solution is coming out properly here. That's it.